Okay, let's follow those same deriving steps to derive the sum of a geometric sequence where we have the numbers for each term. So we are going to derive the sum for the first 6 terms from the sequence 4 plus 12 plus 36 plus 108 plus 324 plus 972. Step 1 is still going to be to rewrite using the nth term formula. So a sub n equals a sub 1 times r to the n minus 1 power. Now, in order to use this formula, we need to know these pieces. We need to know what a sub 1 is, and we need to know what r is. Looking at the sequence, we can tell that a sub 1 is 4 because it's the first term. And then r, remember, you can find by just taking any two consecutive terms and dividing the second one by the first one. So 12 divided by 4 is 3, so r is 3. So let's go ahead and get started rewriting. So s sub 6 equals, for the first term 4, I need to rewrite it as a sub n. So I'm going to do basically a sub 4, a sub 1 is equal to a sub 1, which is 4, times r, which is 3, to the 1 minus 1 power. 1 minus 1 is 0. So I get 4 times 3 to the 0 power. Plus, for the second term, we're going to have a sub 1, which is 4, times r, which is 3, to the 2 minus 1 power. Well, 2 minus 1 is 1. For the third term, it's again a sub 1, 4, times r, 3, to the 3 minus 1 power, which is 2. That was the third term, okay? Now the fourth term is going to be rewritten as 4 times 3 to the 4 minus 1 power, which is 3. Just so you know, as I'm rewriting all of these, you can always check your work when you get to certain steps here, right? Like if I plug into my calculator 4 times 3 to the third power, it still equals 108. So I'm just rewriting them using, again, this equation, this formula right here, so they are all in this form. Still the same numbers, though. For the next term, it's going to be a sub 1 times r to the n minus 1. This is the fifth term, so 5 minus 1 is 4. And lastly, the sixth term will be 4 times 3 to the 6 minus 1 fifth power. All right, step 2 is to multiply everything by the rate. Multiply everything by r. So we're going to do 3 times all of s sub 6. Now, when I multiply 4 times 3 to the 0 power times another 3, remember, when the bases are the same and I'm multiplying, I can condense them together by adding their exponents. So every time I multiply by 3 to the first power, I'm really just adding 1 to the exponent of 3. So this is going to become 4 times 3 to the first power. Again, for the second term, I'm multiplying by 3, which really I can just add 1 to the exponent. This becomes 4 times 3 squared. Oops. Okay, so that's what we're going to do for every single term. I'm going to erase that so it doesn't confuse us. The next term, when I multiply 3 squared times another 3, it'll become 3 cubed. For the next term, when I multiply 3 cubed by another 3, it becomes 3 to the 4th. And for the last one, or the next one, when I multiply 3 to the 4th times another 3, it becomes 3 to the 5th. And then the last one, finally, 4 times 3 to the 5th power, but times 1 more 3 becomes to the 6th power. Okay, now that we have multiplied, we're ready to subtract. I am going to subtract equation 2 from equation 3. When I go through and subtract, I'm now going to rewrite. We are doing the top minus the bottom. So s sub 6 minus 3s sub 6 That becomes S6 minus 3S6 equals, now on the right side, we want to look for any terms that cancel. Like 4 times 3 minus 4 times 3 cancels. 4 times 3 squared minus 4 times 3 squared cancels. 4 times 3 cubed minus 4 times 3 cubed cancels. 4 times 3 to the fourth minus 4 times 3 to the fourth cancels. 4 times 3 to the fifth minus 4 times 3 to the fifth cancels. I'm left with this last term here and the first term way back here. So we have 4 times 3 to the 0 power minus 4 times 3 to the 6th power. Next step is going to be to factor out your GCFs. So I'm going to factor out the S sub 6, and I'm left with 1 minus 3. Equals, on the right side, they both have a 4. So I'm going to factor out 4. I get 3 to the 0 minus 3 to the 6th. Remember that anything to the 0 power, it's just 1. Now my goal is to get S sub 6 by itself. So I need to cancel out anything that's with it. I'm going to cancel out that 1 minus 3 in parentheses by dividing, because it is S times the parentheses. So I need to divide if I'm going to cancel out that multiplication. So I'm left with S sub 6 equals 4 times 1 minus 3 to the 6th over 1 minus 3. Now, here we go. We finished the problem, but can we figure out what the formula might be for any series based on what we have here? So let's try to figure out where these numbers came from. We have S sub 6, and 6 was the number of terms we wanted to sum, right? The first 6 terms. Remember what the variable was that represented the number of terms we wanted to sum? That was n. So really, this is S sub n equals 4. Where did 4 come from? 4 was our first term. So this is A sub 1 times, all right, 1 minus 3. Where did 3 come from? Oh yeah, 3 was our rate. So 1 minus r to the 6th power. Where did 6 come from? Oh yeah, 6 was the number of terms. So to the n power over 1 minus 3 again, which was r. So right here, we specifically, on the left here, this is specifically the sum of the first 6 terms for this sequence. But over here, we can make those connections and find the sum for the sequence of any series with any number of terms.